Hello, in this video we're going to look at a reaction known as the Michael reaction or the Michael addition, which is the 1,4 addition of a carbanion nucleophile to an alpha-beta unsaturated carbonyl compound. But before we go into the details of the Michael reaction, let's look at the resonance forms of an alpha-beta unsaturated carbonyl compound. Maybe we will look at them. Okay. All right. So here is a carbonyl, and if we look at the alpha and beta carbons of this carbonyl, we notice that we've got a pi bond there. So this is an alpha beta unsaturated carbonyl, and this can exist in. It can have two other resonance forms that we could draw. All right. So this one where we've got a plus charge on the carbonyl carbon. And we can draw a second, or a third resonance form rather, where we've got a positive charge on the beta carbon. Now the one on the left is the most important resonance form. However, these two resonance forms show us where the electrophilic carbons are. And that's important for recognizing where a nucleophile might attack this compound. And this video is concerned with 1,4 addition or conjugate addition, so our nucleophile will be attacking the beta carbon here. All right, so the general mechanism of Michael addition is going to look like this. Our nucleophile will attack the beta carbon, and we will move some electrons around, and that's a nucleophilic addition. And we make this enolate ion. And then we can protonate that. We can do a proton transfer to get this ketone here. Now, the textbook will show this getting protonated at the oxygen and then doing its atomerization. I'm showing the simpler mechanism with just two elementary mechanistic steps because we're going to see this type of mechanism when we look at the Robinson annulation. So I'm just going to keep it simple. All right. Now, what this alpha-beta unsaturated carbonyl can be, and also the identity of the nucleophile, can vary a fair amount. And so I want to show you some different nucleophiles, and these nucleophiles would be called the Michael donors. And we can have a variety of nucleophiles. We can have lithium dialkyl cuprates. We can have enamines. And then we can have these carbanions, which are very well stabilized. So you can see we've got two electron withdrawing groups on either side of the carbanion. Okay, and so they're significantly resonance stabilized carbanions. All right. And then we can also have Michael acceptors, and the kind of core structural component of all these Michael acceptors is we've got a carbonyl, and then it's an alpha beta unsaturated carbonyl. And then you can have different atoms or groups here. We could have hydrogen, we could have an alkyl group, we could have a alkoxy group, we could have an amine, a nitrile, a nitro group. Okay, so that gives you a sense of some of the variety of Michael donors and Michael acceptors. So you can see we could potentially have quite a bit of different reactions going on here, quite a lot of compounds we could make. I just want to give you a couple examples here. And so here I'm using this beta diketone. Okay, in the presence of sodium hydroxide, we can make that nucleophile, okay, that we've got here, this carbanion. We can form that enolate, and then that enolate could attack this alpha beta unsaturated ketone. All right, so we're forming a bond between this carbon and the beta carbon here. And so our product would ultimately look like this. Note that this double bond is no longer there. Okay, an important thing to kind of recognize about this is the relationship between these two carbonyl compounds. So here we've got the carbonyl compound, carbonyl carbon, and then if we start going through our Greek alphabet here, we've got alpha, beta, gamma, delta. So we have that pretty long relationship between these carbonyls. Okay. Let's give you another example here. Here I'm going to use a Gilman reagent, or this lithium dialkyl cuprate. Okay, and then after you add this, there's a workup where you add H3O plus. Okay, and you can see here the new carbon-carbon bond we made, and again so this carbon ends up bonding to the beta carbon of the alpha-beta unsaturated ketone. All right, and that is going to conclude this lecture. In the next lecture, which will probably be on the board behind me, I'm going to show, we're going to look at a cross between a malonic ester synthesis and a Michael reaction. And we're going to ask, well, what sort of compounds can we make when our Michael donor is malonic ester? So imagine I replaced one of these R groups with OET, and this was OET. And we can get kind of a neat product or interesting product with that. All right, well, thanks for watching.